So let's say we have a set of vectors. If we're interested in asking whether or not this set of vectors is a basis, we know that we cannot have more vectors than the dimension of our space. So let's say we have m vectors, v1 through vm, that are in Rm. As with almost everything in linear algebra, this will reduce down simply to a question about Gaussian elimination. So we'll take our vectors v1 through vm and we will form a matrix. As we observed previously, for our vectors to span the space, our matrix A must have a pivot in every row. And in order for our matrix to have a linearly independent set of columns, it must have a pivot in every column. So we record this important result as the following proposition. A set of vectors, v1 through vm in Rm, form a basis if and only if the matrix v1 through vn is row equivalent to the identity matrix Im. Now, we recall that such a matrix has another adjective that we can attach to it. This is equivalent to saying that the vectors v1 through vm define a matrix which is invertible. So now that we have a definition and we know how to identify a basis, let's work on a couple of examples.